Last year, the AMRC published a paper on the digital twin, and it went a long way to dispel the myths and terminology around the subject. And I'm joined today by Professor Rab Scott, Head of Digital at the AMRC, part of the University of Sheffield, and also by Jonathan Eyre, Technical Lead in Digital Twin and Advanced Visualization, also from the AMRC. And they're joining me today to discuss the finer points of the paper and to delve into the scope and impact of the digital twin itself, but also how it relates to this idea of the digital thread, and how a combination of these two digital frameworks represent potentially what is the true impact and value of digital transformation for manufacturing companies. Now, I think it's a common misconception that this idea of the digital twin is something new. And Rab, you highlighted this point in the paper, when in fact the idea actually, in some ways, goes back decades. Rab, perhaps if you could expand a little bit on that topic of this digital twin not being something new for us today.
Thank you, Paul. Well, this is one of the challenges that we're facing. Everyone's talking about digital twin, and it's seen as one of the Industry 4 buzzwords that's happening at the moment. But it's causing more confusion and uncertainty than value. And really today, what we're talking about is how we can try and demystify some of that. It's not a new concept. If you look back at the Normandy landings, in Southwick House, there was a model on a table that was updated in real time. Having said that, it was a physical model. You've got people actually getting information from where the Allied forces were over in France and moving it around on the table. So technically not a digital twin. But if you fast forward sort of 25 years from that, the moon landings had digital twins behind them. But the problem there was it was a really high budget environment. The compute power that was required was massive. And really, I think that now we're getting to a stage in technology where the compute power is cheaper. The technologies to connect these digital twins, the IoT devices, are becoming cheaper. And so this is why digital twin is such a in-trend terminology.
Yeah.
Paul.
Yeah. Okay, yeah, thanks for that, Rab. And I certainly think we, in our conversations with customers, we see that this idea that the compute power is cheaper, storage is cheaper, and that connectivity option is exactly that. There are many, many options. And obviously with 5G really just around the corner, I think we're on the verge again of another step change in our ability to quickly connect information, from an asset into a business system, an IoT platform, or so forth. So we've touched on this idea that the digital twin itself is not new, but before we look at what it is, maybe we should try to talk a little bit about what it isn't. And certainly from our perspective, we very much believe that if you don't have that physical asset connected, giving you some sense of real-time information, then you don't really have the digital twin. Is that a fair comment, would you say, Rab?
We would completely agree with that stance. And I actually think that is where we might appear to have conflicting views from many different operators, from many different vendors. But you've got to have a twin of something. You can't have just a simulation on its own. And this is where a lot of that confusion is coming through. Some companies are promoting a simulation as a digital twin, and it isn't. You need a connection from a physical asset to that simulation model. And you've got to have the data connectivity between those two entities. Now, the rate at which that data flows will depend on the use case. If I'm monitoring something that's changing by the second, I've got to have that data flowing by the second. If I'm monitoring a glacier, I probably don't need that same level of fidelity of data at that particular clock speed. It's whatever is appropriate for the use case.
Yeah, and that makes absolute sense, Rab. And I think, again, that that frequency, the refresh rate, whatever you want to call it, of the data that's flowing absolutely is critical, both in terms of the load that you're providing into your infrastructure, but also the cost of that data transmission as well. And we hear a lot about edge compute, edge capability, where a lot of that processing is now being done closer to the edge, closer to the asset, enabling companies to manage those costs and the complexity there. I think also there is a topic around the data rates, as we've just discussed, but there is also the topic around what is it that we're actually twinning. And I think, again, we have today many conversations with customers talking about the physical instantiation of the product that they have out in the field. And, we want, if you like, an ability to do a serial number specific twinning capability. So not just this model, but this particular serial number. And from a PLM perspective, managing variants, managing configurations of products that companies are bringing to market, that ability for us to provide that configuration specific view and a configuration specific twin is critical. And I think that's something, again, where we are looking at today, very closely at how we deliver that capability. But again, we are fully aligned. That idea that the digital twin itself is that you require that physical asset streaming information at whatever the appropriate whatever the appropriate rate is. And so there's no real silver bullet to this idea of the digital twin. And John, if I could perhaps turn to you for some thoughts there on, how you see it from your perspective.
Yeah, definitely, Paul. And I think that is sort of the phrase that comes up a lot is they want a silver bullet of this is how we should architect a digital twin, or this is how we should deploy the technology, and what database technology should I use, or kind of what infrastructure should I have behind this connectivity. And there is no right answer. There's plenty of wrong ones in terms of if it's not good enough or if it can't give you enough bandwidth to have it as what you need for real time. But beyond that, whether it's an asset, process, or enterprise, as long as it's linked between the physical and the virtual, and it can give you the information you need, it can give you the interactive parts that you sort of want to feed back into the physical asset, there's enough bandwidth there or connectivity to enable the predictions using these simulation models to drive the physical assets, then that, as long as the technology enables that, then it's achieving what you need to set out. And as I've often said in the past, it's an approach to how you should come across the technology rather than specific technology, as you said, that silver bullet. I think one of the big things that comes out of this, though, is the condition monitoring. It's such a big area in manufacturing of how can you understand the condition of a machine in real time, allowing for maintenance scheduling, sort of reducing downtime. So all of these holdups that normally happen and what's commonly referred to as firefighting to an extent on the shop floor of this needs fixing, we need to go off and do that, can really be minimized by just having that real-time connectivity, as long as you've got some way of supporting that infrastructure.
Yeah. And I think, again, that is an area that we see many companies looking at this idea of the digital twin to help sort of reduce the overheads that they have, let's say, down on the shop floor. For example, we're talking with one big manufacturer here in the UK. A lot of the business case for that digital twin for the investment they're making is simply that they've got that real-time monitoring of the actual uptime for the machine, the hours that it's actually been running. That then defines, obviously, maintenance schedules and so forth. But at the moment, there is an operations engineer going around and actually looking at the clock as to how long the machine has been running and then noting that down. And if you can simply digitize that, if you can connect that as a simple function of a digital twin, that in itself will provide you with real value as a company. And I think we often see a lot of larger organizations investing in these digital twin models. And with deeper pockets, I think it's often easy to understand how they're able to do that. But I also want to make the point that we see a lot of small to medium-sized companies making similar improvements, but with very modest investments in sensors and the connectivity that is on offer. And I think many of those smaller companies, they do their research, they start on that path, that journey towards that idea of predictive maintenance as the holy grail of what they're trying to achieve. Maybe they want to sort of maximize the machine uptime as a result of that predictive maintenance capability and service just in time rather than just in case. But the reality is that just by connecting the asset with simple sensors, just by having that temperature, vibration, speed, whatever it might be, you can, together with the operator, you can understand a huge amount about the condition of the machine and actually take proactive steps to minimize failures just based on a change in the sensor signature. And we've seen many companies do that with, you know, older equipment, stuff that was designed long before the internet. And I know at the AMRC, you've got an old Boxford lathe, you've got, I think, a Colchester milling machine, you know, that were there and you know, are now instrumented and making that point very, very well. Now, one of the other points I just want to touch on is that in the paper, you mentioned this idea of the asset, the process, and the enterprise, and how that digital twin model comes together to enable this idea of the digital thread. Now, when we position this, we typically talk about this in the sense of three connected pillars within a business. You've got that connected engineering organization as part of the digital thread, and that's all about taking information back into the R&D or product development group, enabling them to do better product planning. Maybe to sort of, if you take a lean principle, designing waste out of your product, why would you design a product with features that nobody uses? And how do you know if they're using those features? Well, that's a function of that connected product. Also for prototype development, we have a lot of companies using ThingWorx to get that information from the prototype in test so they know exactly how it's behaving. So you've got your connected engineering organization. You've also got this idea of the connected factory. And often, you know, that's focused around OEE, around quality, around reducing scrap, reducing rework. And we've talked about this idea of maximizing uptime, but it also goes even further into sort of energy consumption and minimizing the energy usage within the factory, sustainability, and the circular economy. And then lastly, the third part to this is the connected product itself and how it's actually being used in the field. Is it being used the way you want it to? Perhaps if you've got some warranty issues with this particular product coming up, you know, is there an imminent failure about to happen? And if there is, you know, what can you do about it? Is it possible for you to provide an update over the air? Or maybe you want to send, maybe there's the idea that you could send out a self-service capability to the customer using perhaps augmented reality to walk them through how to service the component themselves. Or if you've got to send an engineer, then again, you've got the ability to sort of link them with combined AR capabilities. So I think those three areas together really do combine as three separate digital twins, the concepts, to become the digital thread. And I think, as I say, from our side, that's a very powerful model that potentially combined becomes the true sort of goal for this digital transformation. So lastly, I just want to you know, come back to Rab and John and just ask a question as to whether there are any words of wisdom that you have, words of advice that you would give to companies both large and small as they embark on, you know, this digital thread, digital twin journey. So Rab, if I could come to you first, please.
So my words of wisdom are really based on an old Chinese proverb. The best time to plant a tree was 100 years ago. The second best time is now. And that's really how you should consider adopting the mindset of digital twins. It's never too late to start, but start as soon as you can. Because when you start even just exposing data, you start gathering insights that you previously didn't have. And by having insights today combined with yesterday's hindsights, that allows you to drive foresight. And because of that, you can actually become more effective in your manufacturing processes, better in productivity. And it doesn't actually just stop at manufacturing. We are seeing programs, the National Digital Twin Program run by the Centre for Digitally Built Britain, really beginning to look at an ecosystem of connected digital twins to foster better outcomes. Yes, that's focused on the built environment, but why should it stop there? You know, if you've got a digital twin, the world is your oyster.
Okay. Okay. Thanks, Rab. John, any last points you'd like to make on the topic?
I think the main point for me is start small, is connect something, understand how that affects your business, be that machine utilization, be that energy utilization of how can I save pounds on pence on lighting of a building, or what machines are running, or even the SME that we worked with recently, they wanted to look at the utilization of their lathes. Do they need to invest in a new lathe to help reduce the bottleneck, or is it because they're not prioritizing it the best of what they can do on their shop floor? So I think for me, it's certainly start small, connect some data, and start to understand, as Rob said, the insights that you can start to gather.
Okay, great, thank you. And I think, again, thanks, gents. We certainly see examples of this both in large companies and small. So again, one of the business cases, to your point, John, one of the business cases that we've worked on quite recently with a customer was about improving the uptime of a machining center or a group of machining centers to offset the need for them to actually purchase a new one. And again, it's not that you've got to, bring that up, that uptime up by a huge number of percent, because of the cost of this equipment, because of the cost of the hourly cost of them, the ability, if you can just impact that by sort of 2 or 3%, then the potential there, the potential gain is huge, saving that company a considerable investment for a sort of, a new machining center. But we also see this in much smaller companies as well. And we've touched on this idea that as an SMB, you may feel that this is something just for the larger organizations. But we've seen huge success with some very modestly sized customers. One that comes to mind is TCS over in Ireland. They make granule handling equipment for injection molding machines. They had a traditional make-buy model. They are now selling as their products as a service. And they've been able to do that by connecting the asset, connecting the equipment that they provide and delivering those dashboards to the customer. So they're now charging for the per gram or kilogram of material handled rather than the actual unit itself. And again, that's provided better uptime. They've got better efficiency out of the injection molding process as a result of the dashboards that they've been able to provide. So again, opening up a new business model, a new way to bring your product to market. So again, we see larger companies making big strides here, but we also see smaller companies working perhaps even more innovatively in finding ways in which this connected data, as John mentioned, getting it started, just start to do something, start to gather your information, and you'll find ways of using that in ways that perhaps you hadn't seen at the beginning. So that's it for today. I'd like to thank Professor Scott. I'd like to thank John, both from the AMRC, for their insights into digital twin and digital thread. The paper that they wrote is available on the AMRC website. You can find that if you put AMRC into Google, and it makes excellent reading as a reference point about the history of the digital twin, as Rav mentioned, going back to the wartime days, right the way through to where we are today, and the networks, the connectivity, the ability for you to start on your connected asset journey. So thanks very much for listening. Hope this was useful.